this weekend, I think, is the deadline for the second assignment. Okay. So,
Sir, Monday, no, sir?
yeah, Monday, I think Monday. Yeah.
Yes, sir.
I don't exactly remember. Yeah, probably Monday. Yeah. So, so that is one thing. And so basically, the portion we covered uh, in there, okay, is basically, up till operator overloading, right? So classes, different kind of, constructor, destructor lifetime, okay, and then up till operator overloading, right? So those are the features you will utilize for that assignment, and that is what we have been discussing, uh, you know, till the last class. Okay, so this is the sort of, you can say, like the basic of object oriented programming, right? So now today we go into the another important aspect of object oriented programming, and this is also so the aspect is called inheritance. Okay, so I'm sure most of you have heard about it. Okay, so uh, so basically, so again, this is a very core aspect or a core feature, you can say, of object-oriented programming, and yeah, so you can say that this is kind of one of the most important features of object-oriented programming, and most object-oriented programming languages will support inheritance. Okay, so I think almost all of them, they support inheritance, though the extent of support may vary from language to language, but this is again a general concept in object-oriented programming. Okay, and okay, so let us start our discussion. Okay, so what is this? So while the inheritance is a feature of this, the language, in this particular case of C++ language, okay, which we are discussing. So we will discuss, everything in the context of C++ here. Okay, uh, but it tries to achieve some kind of a design objective, right? So what is this design objective? So what we will what we will try to convince you is that it basically allows you, at least one of the design objectives, it basically allows you to encode what is called a easy relationship between objects. Okay, so yeah, so what is this easy relationship? Okay, so the easy relationship is basically, you can think of it as a generalization specialization relationships. Okay, so let us I mean, it's best to explain it with an example. Okay, so this is a very simple example that we are putting here. Okay, so rose is an object. Okay, a flower is also an object. Okay, though it's a very general type of object, it is still an object, right? And so there can be different roses and there can be different flowers. Okay, now a rose is a flower. Okay, so flower is, you can think that flower is a generalization of rose. Okay, and rose is a specialization of flower. Okay, so so this is the easy relationship. Okay, so in the same spirit, a red rose, okay, is a rose which in turn is a flower. Okay, so red rose is a specialization of rose. Okay, and rose is a generalization of red rose. Okay, so when we are in your programming paradigm, okay, so what are you trying to do, right? So you are trying to model different objects, right? And different types of objects. So that is why you define different classes, right? So you are trying to describe in your programming paradigm, your programming language paradigm, different types of objects and what they provide and how they interact with other objects and so on and so forth. So in that in that context, okay, this inheritance allows you to encode this kind of a is-a relationship or generalization specialization kind of relationship between types of objects, which is basically the classes that you define. Okay. Okay. Now, how does this work? Okay. So, so the way it works. So here are some more examples. Actually, you can think that a two-wheeler is a vehicle. Okay. And three-wheeler is also a vehicle. Okay. So basically, a vehicle is a generalization of two-wheeler, and two-wheeler is a specialization of vehicle. Okay. Similarly, a manager is an employee. Okay. So a manager is a specialization of an employee. Employee is a generalization of a manager. Okay. Okay. So so how does this work, right? So so one of the things of this generalization specialization relationship is that the general class will have some properties, and all the properties of the general class will also be present in the as properties in the special class. Okay, the special, the derived class. So basically, we will see that basically the general class is also called the base class, and the special class is also called the derived class. Okay. Um, so here is an example, like, so flower may have some properties, like it may have fragrance, it may have petals, etc. Okay. Rose will have all those properties that a flower has. Okay. In addition, it will have some other properties. Okay. So the special class will have some additional properties which the general class will not have. For example, rose may have a special type of fragrance, which is the rosy fragrance. Okay. Similarly, between red rose and rose. Okay. While rose will have all the properties of flower and rose. Okay. Not every rose may be red. Okay. But red rose will have a special property that its color will be red. Okay. So this is the idea. Okay. Now, as you can see, there can be many different types of such is-a relationships. Okay. So the first one is so first one is the single is-a relationship, which is that the first example, which is that manager is also an employee. Yeah. So manager is also an employee. Okay. So every manager is an employee, but every employee may not be a manager. Okay. And you sort of so there are these diagrams that we are showing here. So where basically we represent this kind of a is-a relationship with a arrow from the special class to the general class. Okay. So okay. So so this also has significance when you later in the course you will look at UML class diagrams and these kind of things. So you will see more types of relationships and so on and so forth. But you will basically form a lot of diagrams like this when you try to design your software, which you will see later in the course. Okay. So so now here what So how do you write this in C++? So you write it as, first you have to define this class employee, okay, which is the base class, which is also called the base class, okay, and then you write it as though write it like this, that class manager colon public employee, which means that you are defining a derived class called manager, which inherits, okay, the properties of the class employee via this public inheritance, okay. So for the time being, we will not get into this public inheritance. So you assume that everything, this everything is, so inheritance is always public, okay. So we will see the other types of inheritance and their quirks in a few classes, okay, maybe 1 or 2 classes, okay. But for the time being, don't pay much attention to this, okay. So you think that this is public inheritance is the only form of inheritance, okay, and so the manager is inheriting all properties of this type employee, okay. Okay, so this is this way, this scenario where there is one base class, which is the employee, and there is one derived class manager, which is inheriting from the base class employee, is called a single inheritance, okay. Now there can also be a situation of hybrid inheritance, okay. What is hybrid inheritance? So this is a hybrid inheritance, that there is a base class vehicle and there are many children classes or many derived classes at the same level, you can say, of the vehicle class, okay. And all of them are inheriting the properties of the vehicle class. So two-wheeler, three-wheeler, four-wheeler, you can say, okay. So none of them is so they are related to each other in the sense that they are all vehicles, but they are not necessarily inheriting anything from each other, okay. So this is how you do it. So you first define the class vehicle, then you define the class two-wheeler, which inherits from the vehicle, and then the class three-wheeler, which also inherits from the class vehicle, okay. So this is called hybrid inheritance, okay. You can also have a multi-level inheritance, which we discussed, which is that red rose is a rose, okay, and rose is a flower. So here, first, rose is inheriting all the properties of flower, okay, and then red rose is inheriting all the properties of rose. So indirectly, it is also inheriting all the properties of flower, okay. And in this case, this is how you do it. So you basically say that class flower, then class rose is inheriting flower, and class red rose is inheriting rose, okay. So this is the multi-level inheritance, okay. Okay, now yeah, so again, we are looking at this example of phones, okay, and we are looking at basically two types of phones, okay, so or three types of phones rather, okay. So we are looking at a landline phone, okay, we are looking at a mobile phone, and we are looking at a smartphone, okay. So maybe landline phone has facility to call, but it has only the facility to call via dial or keyboard, okay, and it of course has a facility to answer a call, okay. Now mobile phone, of course, it has the facility to call via keyboard, okay, but it also, let's say, shows a number, okay, so it has a screen, it shows a number, okay, so it can also call by number or by name, okay, so it has an address book and you can call people by name, okay. It also has the facility to answer a call, of course, which is there in landline phone also, okay. It has the facility to redial a previously dialed number, It has the facility to set a ringtone, and it has the facility to add a contact, number, name, etc. Okay. So this is a normal mobile phone. Okay. So as you can see from the, from the properties of this type of object, mobile phone, you can see that this is actually a specialization of this landline phone object. Okay. Uh, landline phone class. Okay. Now another thing is, let's say, smartphone. Okay. Okay. So it allows you to call by touch screen. Okay. So okay, and inside the touch screen, there is a virtual keyboard, or yeah, so you can call by a virtual keyboard. Okay. Of course, it shows the number and the photo of a person. Okay. And you can call by number or name of a person. Okay. It has the facility to answer, redial, set ringtone. Okay. And you can add contact. There again, you can add number, name, and let's say photo of a person. Okay. Now, what do you see? So there exists substantial overlap between functionalities of phones. Okay. A mobile phone is more capable than a landline phone and can perform almost all of its functions. Okay, a smartphone again is more capable of more capable than a mobile phone, and again can perform almost all of its functions. Okay, so these phones then belong to a specialization generalization category. So when you are thinking about designing your program, so you can think like this, that you are providing different types of objects. Your program needs different types of objects. Okay, so is it that there is a substantial overlap between the type of information that you are storing, or the type of behavior that we are showing, right? So we have discussed this. So there are broadly two things. One is the state of an object, other is the behavior of an object. State of an object is the variables that you store, and the behavior is basically the functions, the member functions that is have, and the functionalities that is provided. So suppose there is a lot of overlap between these. Okay, then you can think of using inheritance to construct a class hierarchy like this, which encodes this generalization specialization relationship. Okay, now one of the big advantages, so there are many advantages, but one of the big advantages of this, as we shall see, is what is called the reuse of code. Okay, so the question may come that why would you want to do something like this? So there are many reasons why, so we will see all of them one by one, but the reason that is immediately apparent, okay, is that you can use it allows you to reuse your existing code. So for example, if you have defined a call method, okay, which calls by keyboard in the landline phone, and let's say you are deriving this mobile phone from landline phone, and the same call by keyboard method is available, you can directly inherit that particular method from landline phone to mobile phone. Okay, so so this reusability not only reduces your effort to code, so that is one part of it, but it also keeps your code very organized. Okay, so for example, one of the important thing is that, let's say there is a change. So if you are reusing code, okay, let's say there is a change at a later time in one of the codes. Okay, if you were simply copy pasting the same code in 10 different places, then you have to make that change in all those 10 places, and this may result in a mistake that you do. But if you are able to directly reuse the code from one place to other, then you have to just make the change in one place. Okay, and it will automatically be reflected in all other places where you are reusing that code. Okay, so that is the other big advantage of reusing the code. Okay. So any questions or comments till now? So we are sort of discussing a little bit, subjective things about the coding here. Okay. 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 Yeah. So this is the semantics of inheritance. Okay. So the derived class is related to the base class with this is a relation. Okay. And you put an arrow from the derived class to the base class. Okay. And we have seen this, that you first define the base class, and then you have to define derived class with colon and then the type of inheritance and then the name of the base class to sort of signify that you are actually inheriting everything from the base class, and then you define. Okay. Yeah. So this we have discussed. Okay. Yeah, so this is again like the semantic meaning of this public inheritance as given by this as given in this Scott Mayer's book. Okay, which says that everything that applies to base classes must also apply to derived classes. Okay, so this is the key thing when you are doing derived classes, because every derived class object is a type of base class object. Okay, so this is what it basically means. Okay. 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 So now we see the semantics, that how this. So once you do the inheritance like this, how does everything changes? Okay. So the derived class inherits all the data members of the base class. Okay. Derived class may add data members of its own. Okay. So these are the things in terms of data members that you do. Okay. Derived class inherits all member functions of the base class. Okay. Now there are, in terms of member functions, there are two types of facilities which are available. So one is that the derived class may override a member function of the base class by redefining it with the same signature. Okay. We will come to this. Okay. So and then a derived class may also overload a member function of the base class by redefining with the same name but a different signature. So this is the normal function overloading. Okay, member function overloading, just like any function overloading. Okay. Okay, we will look at this thing. Is there a question?
Yes, sir.
Yes, sir.
Yes.
So what
So
does
what does
signature mean?
signature
Does it mean parameters?
Parameters, yes. So no, actually signature means everything, right? So signature means the whole declaration. So the return type, the name, and the parameters all taken together.
But sir, in the third point, it is specifically written the same name. But in
Yeah.
the second point, it is not written the same name. So
Yes.
the signature.
Yeah. Let me explain. Okay. So let me let us go to an example. I think we can just let us go to an example and we will see. Okay, just hold on a minute. So I understand your confusion. Okay, I will clarify it with an example. Okay. So let me just clarify it with an example. So we will just shortly go to this thing. Okay. 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 Yeah. So just hold on to that question for 2 minutes. Okay, I'll come to that. Huh? So let us go one by one. Okay. So yeah, so as we have discussed, the derived class inherits all data members and it can add its own data members. Now, you know that there is obviously a kind of an object layout. Okay. So the object layout is basically all the members of all the data members of the derived class type, right? So it's a map, and we have seen this that there is a construction of object layout that happens. Okay. Now the derived class layout, okay, contains an instance of the base class. Okay. Uh, okay. And then the derived class layout will also have an instance of its own data members. Okay. So for an object, let's say if you look at a derived class object, okay, it will have an instance of an object of the base class within it. Okay. In addition to that, it will have its own objects, its own data members that it has added. But there is no guarantee as such that how these things will be organized inside the derived class. Okay, so the overall layout is not guaranteed, but what is present is given. Okay, so here is an example. Okay, so here we define a class B. Okay, so B has this data member data 1B and data 2B. Okay. And now this class D inherits the class B. Okay. So by default, it inherits data 1B and it also inherits data 2B. Okay. And it defines now this info D underscore. Okay. So it adds this info D. Okay. So now when you define two objects, one object small b of type B and one object small d of type D. So here is what object small b looks like. It has data 1B and data 2B. Okay. Now object D looks like this. Okay. So it has an instance of object B inside it, which is data 1B and data 2B. Additionally, it also has a info D here. Okay. Now notice that, so we haven't gone through the access specification yet, but notice that data 1B is actually not accessible inside the member functions of this class D or this object D. Okay. But an instance of it is present nevertheless. Okay. So this is the key thing to remember. Okay. Okay. Now, now we come to member functions. Okay. So we have discussed this. Okay. In additionally, so we will see what a signature is in a minute. Okay. But we have just like so it can do all these. Okay. It inherits all the member functions of the base class. It can override, it can overload. Okay. In addition, of course, it can add new member functions. Okay. Now, static member functions and friend functions. Friend functions are not member functions, as you know, because their name is not qualified by the namespace. Okay. So so these are not inherited from base class to derived class. Okay. Yeah, so this is something to keep in mind. Okay. Okay. Now, yeah. So now, what do we mean by signature? Okay. So here, when you take the return type, so this whole thing is a signature. Okay. So the entire declaration, so void f int I, the whole thing together is a signature. Okay. Now here we have this base class B, which has void f int I and void g int I. Okay. And then we define this derived class D from base class B. Okay. So it obviously, inherits the F and the G here. Okay. Now to look at this right hand side here. Okay. What it is doing? It is furthermore doing the following. Okay. See, it is now defining another member function. Okay, so it's just doing the declaration here, but basically it will at some point define this another member function which has the same signature as the function here. You can see this, right? Okay, so void f int. Okay, same signature here as void f int. So this is what we mean by same signature. Okay, now what happens here? Okay, so if you create, let's say, an instance D of derived class D, okay, what you can do, just like so the first two calls are simple calls. Okay, so these are the base class calls. So you can call b.f with some integer, and you can also call b.g with some integer. So this is the normal call. Okay, now here you can also call d.f here. Okay, now what is happening? It is calling actually b colon colon f here in this particular case. Why is that? Because as we discussed, it has by default inherited, because it has inherited the class, it has also inherited this particular f here. Okay, okay, so this is the thing here. But now look at the right hand side. Okay, here when we call b, it is usual. When we call d.f here, you see it is now calling d colon colon f and not b colon colon f. So what has happened? This definition of f, okay, has overridden the definition of its parent class or its base class, which is this b colon colon f.
So sir, here like do we need to write the body of the function also, or just the prototype?
So of course, yes, of course. You have to define the function somewhere. Okay, so here you are just declaring, but you have to define. Otherwise, it doesn't make sense, right? It will give a linker error. So if you define a new function, but declare a new function, but don't define it anywhere, it will give a linker error, right?
Okay.
So okay, so okay, so okay, so now you see, okay, so this is one thing. Okay, now the second thing is that here you see what is happening here is that you have the same name. So the name of the function is same. Okay, void. Okay, but the function does not have a same signature. And why does it not have the same signature? Because its parameters have changed. Okay, so so now it is taking a reference to a string. Okay, so this is a overload. Okay, so this is the overload of this function. Okay, so actually this is because you already have another d colon colon f. So this is actually an overload of d colon colon f. Okay, this is not an override. Okay, this is an overload of d colon colon f because it has a new signature. Okay.
So overload of d or b?
It's a overload of d colon colon f because you see you have already declared this d colon colon f. So this should be d colon colon f. Okay, because so it is the overload of d colon colon f int. Okay. Okay, so basically, if you at the end of the day, what it means that if you call something like d dot f with this red, something like this, so it will actually call this version of the function. Okay, so it will call d : f string ampersand. Okay, so this is what it means. Okay. Now, of course, you have neither overloaded, you have not basically overloaded this g int I. So when you call d dot g int I, it will still call the parents function, parents version of the function, which is b : g. Okay. And of course, you have defined a new one. Okay, here. So it will call, the d : h. Okay. So this is what, so this is what it means. So you can see that naturally now this whole generalization specialization principle is coming in. Okay, so what is happening? Okay, so here you can think that these are the general versions of functions. So so maybe in case of suppose your base class was something like animal, and the derived class was dog. Okay, so dog is a type of animal. Okay, then there may be a general version of the function which says make sound, and it makes a general animal sound. Okay, but when you come to dog, okay, you can override this make sound function to say bark or something like this. Okay, so that is the typical semantics, that you can specialize if needed. I mean, by default you are getting the functionality of the base class. Now if you want to specialize in that functionality in the derived class, then you basically do a override. Okay, and then you can of course add all the nuances, like you can add new functionality by either overloading it. So it's adding more different types of, it's expanding the functionality of the same function name. Okay, and you can also of course expand the functionality by defining new function, something like h. Okay.
Excuse me, sir.
Yes.
So by overriding, does it mean that we can never call the f function in the class B?
So you mean b : f, right?
Yes, sir.
Yes, you can call it by calling it b : f.
Okay.
Okay. Okay. Okay. So
Sir,
yes.
sir, we cannot access the data members of the base class in a derived class.
We are coming to that. So that's a good question. Yeah. So just hold on for 1 minute. Okay. So that is the next topic. Okay. Not the next topic. So yeah. I think the next topic. Yeah. Okay. Okay. So now we come to this access specification topic. Okay. So what is this access specification thing? Okay. So so here is the thing. Okay, a derived class, okay, cannot access private members of the base class. Okay, of course they can access the public members of the base class. Okay, but there is nothing special there, that since it can, public members of the base class anyway can be accessed anywhere. So in particular they can also be accessed in the derived class. So these two behaviors are as usual. Okay, now this is where this protected access.
Sir,
Yes.
sir, we are not able to access the private members of the class, and we are able to access the public members of the base class. So, sir, what would be the use to means make a derived class of the base class, sir? Like, what would be the
I'll come.
particular use, sir? Okay, sir.
Yeah. So see, this I understand this question is there in your mind. See, one thing is you have to think like this. So when you design, when you design, it will become much clearer. But I'm just stating it now for your reference. Okay. see, one way to think is that why you made it private in the base class, right? Because you don't want it to be accessed from anywhere, not even a derived class. Okay. So you can ask the question that how will I affect that particular member, a private member in the base class? Okay. So one simple thing can be that you can have a public get set function, okay, in the base class itself. Understood? Understood.
Yes, sir. Yes,
I'm
sir.
not saying
Yes,
that
sir.
is the ideal way to do it, but this is one way you can basically access it. Okay. But let us come to this. This is the most more interesting case in this particular case that so let's say um, um, let's say you what C++ allows in this context, in the context of inheritance, is to specify a member function, a data member or a member function as protected. Okay. So what does this mean? Okay. So if something is protected in a base class, okay, it can be accessed in a derived class. Okay. But it cannot be accessed in other classes, okay, which are not in the same class hierarchy, or in the global functions. Okay, so a new protector is introduced for the base class. A derived class can access protected members of the base class. No other class or global function can access protected members. Okay, so so if you in a base class, if you define some particular data member as protected, it cannot be accessed by other classes or global functions. Okay, so from the point of view of the other classes or the global function, it is like a private. Okay, so it is not accessible. Okay, so you are maintaining encapsulation. Okay, from the point of view of the derived class, okay, it is like public because it can be accessed. Okay, so this is what protected means. Okay.
So protected data members will not be accessed by the friend class also.
Protected data, no, but friend class can have access everything, right? So friend class can access private, so obviously they can access protected also.
Okay.
So okay, so the way to remember is I mean, it's all gets a bit confusing. So the simple way to remember it is probably that a protected member in a base class is like a public member in a derived class, and it is like a private member in other classes which are not a derived class of this class. Okay, in other classes or global function. Okay. So this is how it works. Okay. Okay. So yeah. Here is an example to demonstrate what we just discussed. Okay. So if you again same B and D. Okay. And you are having this print function. Okay. Here. So so basically it is printing the the object. Okay. So here it is all fine. It is saying it has data underscore, which is of course private here, and it can print it here. Okay. Now here, now this is private here. Now note that D, so D is defining another data which is info. Okay, so D actually has both data and info. Okay, but this data is inaccessible here. So this will result in an error. So you cannot say cout data here. Okay. Now, how do you fix this problem? So simple way to fix this problem is that you basically make this data protected. So it is accessible to child, but inaccessible to others. Okay. And now you can write something like this, that you can say D object, and then you can print data and info here. Okay. Okay. Yeah. So And this is, of course, in both cases, you cannot access from outside. So if you try to do b.data is equal to 5, it will not work. Okay, so your encapsulation is maintained. Okay. 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 Now, okay. So this is now what we were discussing here. Okay. So if you have a friend function here, okay, the friend functions or the static member functions, okay, they are not inherited. Okay. So for example, here, you have this overloaded operator, which is a friend operator, okay, which is basically the the output operator, which is overloaded, okay, and it is printing b.data here, okay. So it will not it will not directly get added to here, okay. So if you try to say cout : d, what will happen here? So see, so first see that b is initialized as b0. So okay, we are not showing the constructor here, but you can think that the constructor of b is basically initializing this data member, okay, and the constructor of d is actually, we will come to the constructor, okay, but for the timing, just assume that basically this data underscore is initialized as 1, and this info underscore is initialized as 2. Okay. We will see how to do that in a minute when we describe the constructor and destructor. Okay. But imagine that that is what is happening here. Okay. Then what is happening when you are printing b? Okay. It is saying, it is invoking this object. So b object 0. Okay. Now, when you call cout output operator, or greater less than operator d, okay, it also calls this version of the operator. Okay. So how is this happening? So what is happening here is actually, you see, an object of this type D, okay, it can also be converted to an object of type B, okay, and then this function can be called. Okay. So basically, since now so this D is basically sort of converted to this type, okay, and then this thing is called, okay, and then what it is doing is it is printing B object 1, okay. But if you now overload using a friend function here, okay, the the operator less than, okay, then it prints correctly here. Okay, so it prints so first of all it says D object, okay, okay, yeah, so actually that is not here, but as you can see that yeah, so basically it will print 1 and 2. Okay, so it will print the data and the info. Okay. Okay, so okay, so is this clear? So the bottom line is that for the friend function you have to again redefine here. Okay.
Sir,
yes.
Sir, when the object D is converted to B, so do we lose the extra data members that we declared in class D? Means
hold on to that. We will look at it, probably not today. So there is a explicit mechanism of type conversion from in hierarchy. Okay, so we will look at it. So we will see it in 1 or 2 classes. Okay, so hold on to that. So it's yeah. So just hold on to that question. Okay, so when we come there, we will discuss what happens. But yeah, so yeah, so it can be done. Okay, so we will come there. Okay, so let's not get distracted right now. Okay, so now I just want to finish this constructor destructor thing, right? So we saw the code last time. So how do you define the the constructors and destructors of the classes and how they are called? Okay, so basically let's say you have this base class here. Okay. So the same base class B, which has this protected attribute called data. Okay. Now you are defining a sort of constructor for B, which has a defaulted parameter. Okay. So and you are basically initializing this data with this value D. Okay. And then you are sort of printing this. This is just for diagnostics. Okay. And similarly, you are just defining the destructor, and you know that this is also printing things for diagnostics. Okay. Now, when you come to the derived class, okay, you have added this new data member. So what do you do? So you you define this constructor something like this. Let's say that int d and int I. Okay, so you can also default this. We have not defaulted it here, but you can also, it's a good idea to actually default them. Okay. Now you so what do you do? So you first called the constructor of the base object. So this is what you are doing. Okay, so you're calling the constructor of the base object with this data. Okay, so that is doing the construction here. Okay, of the base object. So remember that the derived object has an instance of the base object instance. So this is inside it. Okay, so this constructor is basically creating that instance of the base object inside the derived object. Okay, and then you are of course instantiating the newly defined member, which is the info. Okay, and then you are printing some diagnostic information. Okay. Okay. So here is another constructor, which is basically just initializing this info. Okay, and it's it's not calling the constructor of the base class explicitly. Okay, so basically what is happening here, the default constructor of the base class is being called. So if there is no default constructor of the base class, then this will give an error. Okay, so if you don't do a construction of the base class object, and if there is no default construction of the constructor of the base class, then this will give an error. Okay, so which is why, I mean, we always should have, it's a good idea, good programming practice to always have a default constructor, right? So okay. Is there a question?
Yes, hello sir. Yes.
Yes.
Actually, sir, if we have don't have a default constructor, then the compiler provided constructor won't be there. Means
No, remember we discussed that if you provide even one constructor, okay, then the free default constructor is not provided by the compiler.
Yes. Okay, sir.
Okay. Okay. So okay. So okay. So now you see here that okay. Okay. So here is the idea. So if we create like B5, okay, basically we are creating this object B, which has this 5, and if we create this D, this D112, let's say, okay, So again, the first constructor is getting called, okay, and you get an object with you know, the base object value initialized to 1 and the info initialized to 2. Okay. Now, if you call d2 3, okay, basically the default constructor of the base object is called. So the base object value is initialized to 0, okay, whereas the info is initialized to 3. Okay. Okay, and this particular slide basically shows how, in what order things are done. So again, the same thing we are doing it here. Okay, so you see, first this b:b int 0 is printed. Okay, so this is corresponding to this particular object creation. Okay, so only base class constructor is called. Okay. Next, for the object creation of D1, you see, first the base class constructor is called with argument 1. Okay. And then the derived class constructor is called, yeah, so basically it is called with, you know, it is called means the body is executed with, you know, arguments 1 and 2. Okay, so you see here we are printing both data and info here. Okay, so it is only setting, so it is directly only setting info, but it is calling the base class constructor, which is setting 1. Okay, now if in the second case, when you are only calling with one integer, okay, so it is calling this version of the constructor. Okay, and here you haven't explicitly called it, but since there is a default base class constructor here, so again that default base class constructor is called with the value, default value, which is 0. Okay, and it prints this. So this particular constructor is again called, but with default argument. Okay, and then again the destructor is, the body of the not destructor, but the derived class constructor is executed with 0 and 3. So this is printed in this order. Okay, and now the destruction order is also clear. You see, of course, as you remember, the objects are destroyed in reverse order as they are created in the function, right? So everything when it goes out of scope. Okay. So first, this object, you know, the destructor of object D2 is called. Okay, and then the destructor of object, you know, the base class object inside the object D2 is called. Okay, so this is the order. Okay, so reverse order it is called, and similarly then it is called for the object D1 and then for the object D. Okay. Okay, so I think, yeah, so this concludes, you know, our basic discussion. Okay. So any questions or comments? So yeah, so you know, think about it. Yeah, so we will, you know, continue the discussion in the next class.
Sir?
Yes.
Sir, when we call D means with a single parameter, the constructor of D, so is the constructor of base class invoked first and then info is initialized?
Yes. So it does not matter. So always base class constructor will be called first and then the derived class constructor will be called. Okay. So is it clear? So here, because we have a print statement inside the defaulted base class constructor, we can actually visualize that. Is this becoming clear? So suppose, you know, we did not, provide any constructor to the base class, let's say, right? So it will provide a free default constructor. Okay. In that case, also the base class constructor will be called first. The base class object will be constructed, and only then the derived class constructor will be executed. Is it clear? If you remember from our discussion of constructor, so what happens is first the memory allocation is done and then the constructors are called, right? So the object lifetime starts from after the memory allocation and just before the execution of the constructor body, right? So that is when the object lifetime starts.
Yes, sir.
Sir,
Yes.
sir, in the initialization list of a constructor, the format is like we write variable name and we pass in the value. Now here we are directly calling the constructor of base class. Then what exactly are we initializing? Because here there
Right.
is no such object involved.
What exactly are we initializing? Okay.
Yes, because
Yeah.
capital BD just calls constructor of base class, but where is the object?
No. So see, that is the that is the beauty of the semantics. You can the syntax you can say here. This is so this is so you cannot say that this is calling the constructor directly. This is actually doing an initialization of the base class object, which is implicitly there in this derived class object. You can think about it like that. So the initialization involves calling the constructor. So this is still the initialization, okay? But you remember, so any kind of initialization that you do. So okay, so let's say there is no. So let's say in this derived class D, you had something of type some object of a certain type. Okay, so then here you will call that particular object followed by and then let's say that has a copy constructor. Okay, so you can call like a you can call that object you can initialize that object to this, right? Am I
Yes.
am I making sense here? So yeah, so you can think that so I think your question is what are we exactly initializing here, right? So we are initializing the base class object which is implicitly there inside this derived class object. That is what we are initializing, and as a process we are calling the constructor.
Okay, sir.
Okay, that's a good question. Yeah. Any other questions? Okay then. Thank you very much, everyone.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Sir, excuse me, sir.
Yes.
I had a doubt in the assignment regarding what is the intended use of the buffer in the first question. I mean, should it be used as the storage, as the memoization of only the primes that